Welcome from the famous Copacabana beach here in Rio de Janeiro in Brazil. I'm currently here attending the 2019 IPDPS conference, and I will be having a talk and a poster on our paper on transparent access to 5G edge computing services. If you have any questions or feedback, just contact me directly here at the conference or go to edge.josephhammer.com. So, transparent access to 5G edge computing services. Sounds nice, but what do we mean by it? Just as a short recap, when we talk about edge computing in 5G networks, we talk about multi-access edge computing. What actually is edge computing? It's similar to cloud computing, but the computing happens close to the user at the edge of the network, and in case of 5G, that of course means close to the base stations. What are potential use cases? Well, UAV control and communication, vehicle communication, intelligent video analytics, etc., etc. How do we address these edge computing services? Do we want to address them similar to IoT frameworks, where more or less the framework handles everything for you? The thing with these frameworks is that you have a vendor lock-in, and of course you have to learn the framework first. So maybe we want a different approach. Our idea here is to use virtual cloud service IP addresses to access the local edge instance using software-defined networking. We want to access the edge service like cloud service, so we want to move the intelligence into the network. The user doesn't need to know that there is an edge instance at all. What we would like to have is an extended perceived cloud. So the user accesses the cloud service, but the intelligence in the network decides, well, this is an edge service, and redirects the request to the closest edge. In other words, the user never sees that an edge instance is part of the game here. What are the advantages here? First and foremost, we have a simplified development. Developers already know how to access cloud services. Nothing new here. Edge instances are accessed in the very same way. Second, it works with legacy systems. Let's say you have an existing surveillance camera and you would like to process the data before it is sent to the cloud. Maybe you want to filter it, whatever. You might not be able to update the firmware on the camera, or it might be too expensive. With our approach, you could move an additional processing step into the edge without having to modify the surveillance camera, for example, without having to modify the legacy system. As a third advantage, you can have the cloud as a fallback if no edge is available. Since you use a regular cloud service IP address, if you don't have an agreement with the mobile network provider, for example, then the request would simply go through to your cloud service. And there you can decide what you actually want to do with it. Maybe it doesn't make sense to process it. Maybe it does make sense. It's just slower. You just don't have the benefits. It's your decision. And this way you can really start with a small edge first, or with an edge in only a specific region first, and extend later on, and still provide the service to everybody. And finally, it's easy to find the closest edge instance. Since you know exactly where the user request enters the network, you know exactly the closest edge as well. Alright, so how does this routing with a registered service IP work? Well, the user equipment, that is, the user, sends a request to the network. The base station doesn't know this kind of request yet, so it sends a request to the SDN controller, which then checks is this a registered service IP or not. If yes, it sends a redirection to the base station, and from there on, the similar requests are forwarded to the edge service instance, which responds instead of the cloud. So the cloud never sees the request. To test our concept, we implemented an early prototype using the POX controller written in Python using Mininet. Here we test the migration detection. First, the UE is connected to base station 1, so we get the response from edge 1. Then we move the user to base station 2, and we see this migration is detected by the controller, and now we get the response from edge 2. Then we move again the user to base station 1, answer is by edge 1, and we move back to base station 2, answer from base station 2 again. Thank you very much for watching. If you have any comments or feedback, I would love to hear from you, either directly here at the conference or contact me with the contact information provided at edge.josephhammer.com. Again, thanks for watching, enjoy the conference, and have a